Welcome to a video on how to do a leak-down test on a Porsche Cayenne 957S. This video will also include the procedures for removing and replacing the spark plugs, the coils, and the engine bay covers, since those procedures are all required in order to do the leak-down test. This is a detailed instructional tutorial, meaning I've documented every nut and bolt required to be removed and replaced, including with torque specs for how to do this. So I think that this is something that you could use to do this procedure if you've never done a leak down test before, if you've never done one on this particular engine, and it should be very safe to do so. Having said that, there's always the caveat that there are an infinite number of ways to screw things up, so one does this procedure at their own risk. But it's a very risk-free procedure. The only potential risk that I could foresee is because all the combustion chambers are open when the spark plugs are out. If someone was careless, they could drop something into the combustion chamber, which would be very bad. So we want to make sure we avoid that. Also, if there's any dust in the air, that could be contaminating the combustion chamber. So make sure you're in a fairly dust-free environment. Don't sweep the floor immediately before doing this, for example. And I think the biggest risk is just having the butterfinger syndrome that I'm prone to and dropping a screw or a bolt or a nut into the engine compartment. And odds are high if one does that, that it will never be seen again. So you have to try to make sure when you're doing this that you remove things from the engine bay area as soon as you've taken them out, set them aside somewhere safe so that you don't drop them. But we'll be getting into a little bit more detail on that as we move through the video. In terms of the tools needed to do the leak down test, I used a flathead screwdriver as well as a small S-shaped flathead screwdriver, which is optional, and I'll be showing you why as we go through the procedure. Torx 20, 25, and 30 wrenches. Also E-Torx 10 and 12 sockets, and a 3/8 inch ratchet. You'll also be needing a 16mm socket to go on that 3/8 inch ratchet, as well as a 16mm wrench, a magnetic pickup tool, which is optional, but I advise it for one specific part, or in case you do happen to unfortunately drop something ferrous down into the engine bay for retrieving it. A piece of cardboard, a base from a 32 can case of soda is ideal, but anything that, it doesn't even have to be a piece of cardboard, just something clean that you can write on, that you don't care if you write on, that you can throw away. That'll make sense also as you go through the procedure. A marker for writing on that cardboard, a pen and a piece of paper, a thin-walled spark plug socket set, and I'll be providing you later on in the video when we get there with the part number of the socket set that I used. Also a short 3/8 of an inch wobble extension. An 8mm socket, a 27mm shallow 3/8 of an inch socket, a set of needle nose pliers, nitrile or latex gloves, about a 3-foot length of pipe or square tube that's no thicker on its outside dimension than 1 1/4 inches. One of either a straw or a wooden dowel or a piece of drinking water line, as you'll see detailed in the video. Also, optionally, a TDC, top dead center, finder tool, and an oil can with some clean oil in it to put a few drops of oil on an O-ring, as will be explained as we go through the procedure. You'll also need, of course, a leak down tester and an air compressor to use with that leak down tester. And torque wrenches. I used a 3/8 of an inch torque wrench that had a range of 10 to 80 foot-pounds of torque, as well as a 1/4 inch torque wrench with a range of 20 to 200 inch-pounds of torque. Before beginning the procedure, ensure to have the key removed from the ignition of the car, and it's also a good idea if you want to protect your paint to put some protective covers over the front fenders and the front bumper cover. So the first step in doing this is removing the engine bay covers. So here we have the car before anything's been removed from it, and that's what your engine bay should look like with these covers. There's one, two, terrible two, I apologize. One in the back is 3, and then 4 and 5. So you need to remove all 5 of these engine bay covers. And these are the tools that I use to do so. So we have the S-shaped flathead screwdriver, which I said is optional, and you'll see what I use that for shortly. Also, I use a stubby flathead screwdriver. It doesn't have to be stubby, but I find that most comfortable for doing this. And a T20 and T25 wrench. And the first thing that I like to do when I remove the engine bay covers is to remove the cap that sits on top of the windshield washer fluid reservoir. And the way you do that is just to take your fingers and place them underneath this ring that sits around the neck of the windshield washer fluid reservoir and simply gently lift up and it'll pull off. Next, you take a T20 wrench and remove this screw that holds the engine bay cover to the windshield washer fluid reservoir. Then remove the various screws holding the engine cover on. This is the right side engine cover, and I should say I'm going to use the convention throughout this video that Porsche uses, which is the right side of the car is the North American passenger side, or when you're sitting in the car and looking out of the car, the right side. And left side then, of course, would be the North American driver's side. So this is on the right side of the car, and this particular engine bay cover. And I started by removing the steel screw here with a T25 wrench. Next, I remove the plastic screw that's in the front on the vertical of this engine bay cover. And you can see here, this is where I use the short S-style flathead screwdriver. And that's because this mass airflow sensor connector is in the way of a longer screwdriver accessing this screw. So I like to use this little screwdriver that I have. But if you don't have one, don't want to get one for this, which is perfectly understandable. What you can do is disconnect the mass airflow sensor connector, and that should give you access to use a longer screwdriver to come in and access the screw. And it's the same for the other side of the car. So here is one of these black plastic screws that's been removed. It's installed by simply pressing it in and turning it 90 degrees clockwise. So uninstalling it involves turning it 90 degrees counterclockwise, and then it should release. So remove the remaining 2 black plastic screws for the right side engine bay cover. And then to remove the cover, you just place your hand underneath it and lift up a little bit gently, as well as pull out toward the inside of the car, towards the engine side, so that you can get this edge out from underneath the engine bay seal. Next, do the same thing on the left side of the car. So remove the steel screw with the T25. Then use your flathead to remove the plastic screws. And then remove that cover and move on to the removal of the rear cover, which is only held on at this point with one screw in the middle. So remove that plastic screw and remove and set aside the rear engine bay cover. By the way, please pardon the dirty coveralls that you can see that I'm wearing. I had been crawling underneath the car prior to doing this procedure, and this is the winter time, and it was a warm day. My wife had been driving the car earlier that day, and that's what happens when you have sand and salt placed on the roads in the wintertime where I live. At this point, the front 2 engine covers are held on each with one screw. So remove the 2 black plastic screws from the front engine covers, and the right engine cover overlaps the left engine cover. So first remove the right side engine cover like this, then remove the left side engine cover like so. The first thing we have to do to remove the coils and spark plugs is to remove the torque arm from the engine. So to do that, we simply take a 16mm socket iron ratchet and a 16mm wrench to counter hold and loosen the nut off the bolt. Note that the bolt slides through from the front of the engine, so the nut is of course then on the back. Set the nut and bolt aside, and then loosen the other bolt on the other end of the torque arm. You don't remove this, you just loosen it so that the torque arm will swivel up and out of the way, like so. On the right rear side of the engine, you'll see this clamp, which is sitting on a tang on the motor. And you're going to need to release this clamp from the tang and then slide this clamp. I mean, you could remove it, but it's just as easy, I find, to slide the clamp along the hose so that it's out of the way. So to illustrate, here's the clamp pulled off the tang, and here's the clip slid down the hose. You could also unclamp this clip from the hose and set it aside, but I find it easier to just slide it down the hose and leave it there. On the left side of the engine at the rear, we have this positive battery cable that is bolted with an E10 bolt to the valve cover, and it needs to be removed so that we can have access to the number 8 cylinder. This is a high risk for dropping proposition, so whenever I put this back on, I just use the socket to finger tighten it so that I don't have to try to get the E10 socket and then a ratchet in here because there's really not very much room. So the next step is to remove this bolt carefully. Here you can see how much, or more accurately, how little room there is to get a socket and then a ratchet as well on this socket to remove this E10 bolt. This is what the bolt looks like when it's removed. And to be extra cautious, it's not a bad idea to place a magnetic pickup tool on the or near the head of the bolt when you're loosening it, so that in case you don't get your fingers on it when it comes out, that you'll catch it with your pickup tool. So to illustrate why we need to remove this again, this is the situation of having the cable blocking the access to cylinder 8 when it's bolted down, and then in the next slide we'll see that this is how much access you're able to have once you remove that bolt. Next, you need to remove the ignition coil design covers, these fancy covers to cover cosmetically the ignition coils. So you take a T30 and remove the 4 screws on the design covers on each side. And this is what the screws look like that hold on the design covers. With the screws removed, gently lift up from the bottom. Then on the right side of the engine, the right bank, start at the front and pull out. And you'll see that there's a tang that sits in here at the front that is why you need to begin at the front pulling it out. Then work your way toward the back, pulling out the design cover. You can see here that I've got the first 3 out, and there's just the one at the end to go. And there's also a tang at the back that needs to be pulled out. Once it's free, you can remove it. And what you'll then see is your 4 coils on that side of the engine, as well as the electrical connectors on each coil, and that each coil is connected to the valve cover with 1 bolt. Then in the same fashion, remove the ignition coil design cover from the left side of the engine. You can see that the left and right side ignition coil design covers are unique parts. They can't be mixed up, so there is no worry about getting them mixed up when putting them back on. They can only go on one side. Next, you have to disconnect the 8 ignition coils from the wiring harness. To do this, you press down on the tab that's in the middle of the connector, and then you simply and gently pull the plug off. Sometimes it's a little bit difficult to pull off the electrical connector, so what I find myself doing is using my stubby screwdriver to gently pry up on the electrical connector once I first pressed down the tab. So normally I'd have my left thumb pushing this tab in, and then I would gently pry up just to get it started so that I can then pull it off. And for the coil by the torque arm, you can conveniently rest the electrical connector on top of the bracket for the torque arm. Next, undo the ignition coils by undoing the fastening screw on the valve cover using an E12 socket. This is what the bolt that holds the coil on looks like. Next, place your fingers underneath the coil and gently pull it out to remove it. And this is what the coil looks like. At this time, inspect each coil for any cracks or imperfections. When coils fail, they often will have cracks that are visible. Then set the coil aside. I like to reinstall the coils and spark plugs in the same cylinder from which they came, so I label a piece of cardboard and set them aside in that order. Then repeat for the other 7 coils. There isn't much clearance for removing the coil at cylinder 4, but of course it will come out. Once the coils are all out, they've all been inspected to ensure that they're okay, you can move on to removing the spark plugs. This is the spark plug socket set that I use. It's a KD Tools set, model number 41740. Note that you should remove the spark plugs with the engine cool to avoid damaging the threads in the block. So with the engine cool, remove the spark plug in cylinder 1. Inspect the plug for anything unusual, and don't forget to also inspect the ceramic side of the plug as well. Set the plug aside and move on to the next cylinder. For most spark plugs on the Cayenne engine, I use the longest socket from the spark plug socket set, but for cylinder 4 and cylinder 8, the two at the back of the engine, I use the medium socket from the spark plug socket set combined with a short wobble extension. With the spark plugs removed, now you need to remove the air intake Y pipe. Begin by removing the design cover that sits on top of the throttle body. Do so by sliding your hands under each side and gently pulling up. There are 2 rubber grommets on the engine. This is the one on the right side of the engine. They have a habit of sometimes sliding out when you remove the design cover. So immediately after removing the design cover, just make sure that they have stayed in place, or sometimes they'll be kind of half out. You can just push them back in so that they stay in place. Next, using an 8mm socket, loosen the hose clamp on both sides of the Y pipe. Next, use pliers, and I like to use needle nose pliers for this. Turn the pins at the throttle body so that the tang on the bottom lines up with the channel, and then gently lift. I tried to get a good picture of the tang on the bottom, and I have one once it's removed to show you, but I couldn't get one of it in situ. But there's a little pin on the bottom that you'll see shortly that you turn the pin, this is the pin, turn it to line it up with this channel that you can see here. So it's just a little short pin on the bottom that needs to line up with it. If you don't line up the pin with the channel and you pull up on the pin, you can and will break off the little tang on the bottom of the pin. Ask me how I know. So here's the pin on its way out, and this is the pin removed. And here you can see the little tang on the bottom that needs to be lined up with this channel here. Next, wiggle the Y pipe off of the throttle body. You could also, in order to facilitate this, remove these plastic pipes completely from both sides, but I don't find that it's necessary. Once you have the Y pipe removed from the throttle body, then you can begin to work it out of the hose on the left side of the car. And once it's out on the left side, then you can begin to remove it from the hose on the right side of the car. And this is what the Y pipe looks like when it's been removed. At this point, you've removed everything that you need to remove in order to change the coils, change the spark plugs, and do a leak down test on the car. I like to place a nitrile glove over the throttle body to keep dust out. Keep in mind that all 8 combustion chambers are currently exposed to the environment. If you're just replacing the spark plugs, obviously you should only do one at a time to minimize exposure of the cylinders to dust. But for a leak down test, all spark plugs should be removed to allow rotation of the engine into different positions. If the spark plugs were in, the compression generated would make it very difficult to rotate the engine. Now we can begin to conduct the leak down test. What we have to do is position the cylinder to be tested to top dead center on the compression stroke. Since we're going to be doing a leak down test on all the cylinders, we'll start with cylinder number 1 so that we can follow the firing order for easily finding top dead center. To do this, we use a 27mm socket and a 3/8 of an inch ratchet with a cheater bar. One very important word of caution before we get started with this part of the procedure is that when you set the cylinder at top dead center and then you pressurize it with air, what can sometimes happen is it'll cause the piston to move and the engine to rotate. So you want to make sure that you don't have anything in any of these bits that rotate. Especially, you want to make sure that you remove your socket and ratchet from the crankshaft pulley before testing each individual cylinder so that the ratchet doesn't get caught up in here if the engine does try to turn over on you. This is the 27mm socket that I use for turning the crankshaft bolt. It's nice and shallow. It comes from an oil filter kit. However, it's a little bit too wide this way. I don't have a short, regular hex 27mm socket. I only have a deep socket in 27mm, which is why I use this, but a narrower and shallow 27mm socket would be ideal, as I'm going to illustrate next. So this is the depth of my 3/8 inch ratchet with the socket. So this is a picture of the socket and ratchet and how little room there is to actually get it between the harmonic balancer and the plastic shroud for the cooling fan. It's a bit of a challenge to get this into position. It does go, but you can see now why it would be better to have something this shallow, but if it was also narrower like a normal socket, that would be ideal. So here is the ratchet with the socket on the crank bolt. And this is the cheater bar, which is a piece of thin-walled square pipe that's a hair under 1.25 inches thick, placed over the ratchet. You can see that there's just barely enough room to get that 1.25 inch in there. So for your extension for your ratchet, you're going to need to have a piece of pipe that's less than 1.25 inches, based at least on this particular car. And you can see in this picture the leverage that one gets using the extension on the ratchet. It's really the only way to get enough leverage to rotate the crankshaft in this situation. Note that you should only ever rotate the crank in a clockwise direction. So as you're facing it, you rotate the crankshaft in a clockwise direction. If you go past top dead center when you're trying to find top dead center, do not rotate the crankshaft backwards. Resist that temptation. Instead, rotate the engine clockwise, nearly 360 degrees, to get it back to top dead center on the compression stroke. You need to have it the cylinder at top dead center on the compression stroke, of course, so that the intake and exhaust valves are in the closed position so that you can pressurize the combustion chamber to assess for leaks. There are different ways of determining whether or not you're on the compression stroke, but the easiest way is to simply put a coil in place without screwing it down and then rotate the engine. And when you hear air coming out from the seal of the coil, or sometimes the coil will even just sort of pop out, then you know that you're on the compression stroke. So I simply put the coil for number 1 cylinder back in place, rotated the engine clockwise, and I could hear the air escaping around the base of the coil, and that told me that I was on the compression stroke. Then you remove the coil, and I like to use this top dead center finder tool. It screws in where the spark plug goes. So you have to get, if you're going to get one of these, you have to get one that's with the correct threads. And then as the piston pushes up on this spring-loaded part of the tool, it actually pushes out the other end. And there are all these little lines, like what you can see here, which will be shown in a picture shortly, that you can watch as you rotate the engine so that you can get a very good gauge of to when this stops coming up. Once it stops coming up, you know you've reached top dead center. You don't have to use a top dead center finder tool. You can use a piece of wooden dowel or a straw. Sometimes if the straw is not long enough, you could put two straws together, maybe cut to the exact length you need. I use this old piece of water line from a drinking water filtration system. And you do need this for cylinder number 4 at the very least on this engine. That top dead center finder tool will not go into cylinder number 4 due to space restrictions. So with whatever you're going to use to find top dead center in place, then rotate the crankshaft clockwise and watch. And as I said before, this particular tool has these little lines you can see here. And so it makes it very easy to see if it's still moving as you're turning the crankshaft. And when it stops coming out, that's when you know you've reached top dead center. So now that you have cylinder number 1 at top dead center, you can remove the ratchet from the crank bolt and remove the top dead center finder tool, whatever you used in the cylinder to find top dead center. Then get your leak down tester and remove the test hose, the part that threads into where the spark plug goes, and place a couple of drops of clean engine oil onto the threads and the O-ring as shown here. Next, you install the test hose into the engine. Be careful not to cross thread. Because the test hose is not stiff, it would be fairly easy to cross thread it, which would be not good at all for installing your spark plugs and removing them in the future. So what I try to do is use 2 hands, one on the end and one in the middle, to kind of stiffen up the test hose as much as possible, and then rotate it left until I feel it kind of drop a bit or seat, and then start rotating clockwise to thread it in. You want to make sure that you don't over tighten it. You want it to be snug enough to make a seal, but not so tight that it'll be hard to remove. And for some engines, you have to actually use an adapter on the end to fit the spark plug threads. And so you really want to make sure with those that you're not over tightening it, because you wouldn't want the hose to come out, but leave the adapter in the block. Now you're ready to set up your leak down tester. So with your air compressor obviously on and full, you should have your regulator of your air compressor providing at least 100 pounds per square inch of pressure. You then pull down the handle of the leak down tester, the regulator lock. You release it, and before connecting it to your compressed air line, you turn it all the way counterclockwise. Then you connect your air line to the tester as shown here. And then you turn the regulator clockwise, and you can see here I've started turning it clockwise and it's building pressure. And you turn it all the way up so that this needle on this particular leak down tester, the way it's done is it reads actual percentages of loss. So you set this needle all the way so that it's zeroed out here. Double check that you've removed the ratchet from the crank bolt, and then connect the test hose to the tester and check the drop in pressure. Now read the pressure drop. In this case, the pressure drop was about 6%, just past the 5%. So record cylinder number 1 is having a pressure loss of 6%. If that seems unusually high, then what you can do is listen for leaks. So you can remove the radiator cap and look for bubbles to check for a head gasket leak. You can listen for air at the exhaust pipe for an exhaust valve leak. You can open the oil filler or dipstick and listen for air, which would be indicative of a bad seal at the rings or cylinder scoring. And you can remove the glove from the throttle body and listen for air there as well, which would be indicative of an intake valve leak. When you're done testing that cylinder, what you do is back the pressure off in the gauge to 0 and disconnect the gauge from the test hose, and then unscrew the test hose from the spark plug hole. Next, what we're going to do is test the remaining cylinders in precisely the same way we tested cylinder number 1. And we do that by following the firing order. The firing order on this engine is 137-26-548. So the engine's currently sitting at top dead center on the compression stroke on cylinder number 1. So what we do is put your top dead center finder tool, whatever you're using, into cylinder number 3, and then rotate the engine clockwise. Watch your top dead center finder tool until it reaches its maximum height, and you know you're at top dead center on the compression stroke on cylinder 3, and you test that cylinder, and then repeat for the rest of the cylinders. Once you've completed that process on all 8 cylinders, you'll be finished with your leak down test, and it'll be time to put everything back together. And you'll start by installing the spark plugs and coils. So, ensuring not to cross thread, fit the spark plugs. Spark plugs that have already been fitted into the 4.8 liter V8 Cayenne motor are tightened to 19 foot-pounds of torque. Those that are new, if you're replacing at this time while you're in there with brand new spark plugs, they are to be tightened to 22 foot-pounds of torque. Next, you install the ignition coils, and then you install the screws for the ignition coils and torque them to 7.5 foot-pounds or 90 inch-pounds. Note that cylinders 1 and 5, the 2 front cylinders, lack sufficient space, at least with my tools, to get a ratchet, a torque wrench, on them. So those I just approximate to the correct torque. But there's plenty of room on the remaining cylinders to torque to the correct value. Then reconnect the electrical connector onto the ignition coil, and these electrical plugs must engage audibly, so you hear a very satisfying click when they're fully seated. Next, install the ignition coil design cover for the left side of the engine, which is bank 5 to 8, and you start by placing the tang on the back side into the opening as shown. Then work from back to front. Such that the design cover is fully seated, and then you press down on the bottoms to get it fully in place. Next, install the 4 fastening screws onto the ignition coil design cover and torque them to 3 to 3.5 foot-pounds or 36 inch-pounds. Then do the same for the right side of the engine, bank 1 to 4 ignition coil design cover, starting with the tang at the back of the motor and working your way forward. Once it's fully seated along the top, press down so that the design cover will be fully in position. Then install the screws and torque them to 3 to 3.5 foot-pounds or 36 inch-pounds. Reinstall the clamp by cylinder 8 that holds on the positive battery cable, and as I mentioned before, just finger tighten this with the socket, being careful, of course, not to drop the socket or bolt. Slide the clamp on the hose back to its position by cylinder 4, and then reinstall the clamp onto the tank. Place the torque arm back into its position. Install the bolt from the front and then the nut on the back side, and torque the nut to 44 foot-pounds. Then tighten the torque arm fastening screw to 44 foot-pounds. Now reinstall the Y-pipe, of course first removing the nitrile glove from the throttle body. Start the Y-pipe into the hose on the right side of the car. Then work the Y-pipe onto the hose on the left side of the car, and slide the Y-pipe over the throttle body, ensuring that it is seated all the way onto the flange on the throttle body. Orient the hose clamps on each end of the Y-pipe and tighten them with your 8mm, just hand tight. Install the throttle body pins and rotate them a little bit to lock them in place. Install the cover that sits over top of the throttle body. Note that in addition to the 2 grommets that are on the engine, there are also 2 on the underside of the cover, so ensure that they are present prior to trying to install it. Also double check again to ensure that the 2 rubber grommets are still present on the engine. Then simply press the cover into place. Now it's time to install the engine covers. Begin by putting the left front engine cover in position. Simply tuck the cover under the engine bay seal and line up the holes for the plastic screws. Here you can see how the engine cover is nicely tucked under the engine bay seal, and it's also aligned perfectly with the receiver for the black plastic screw. Then install the 2 plastic screws. These plastic screws get pressed in and then turned 90 degrees to the right. They can be a little fiddly, so ensure that they are seated correctly so that they don't pop out on you and you lose them. Next, install the rear engine cover and insert the screw in the middle. Install the left engine cover. Install the 3 black plastic screws and the steel T25. And next, install the cover on the right side of the engine with its black plastic screws, its steel T25, and the small screw that sits at the windshield washer fluid reservoir, which is a T20. Finally, install the cap for the windshield washer fluid reservoir. And you're done. In terms of wrap-up, now that you have all of your data, what you do is compare the results of your leak down across the cylinders of the car. In this case, it ranged from 5% to 8%, which is considered acceptable. 3% difference across the cylinders is not a big deal at all. And also, what I like to do is compare the results to past tests that I've done. So if you're doing this like I am, as sort of a routine, kind of every couple of years, check on the health of the engine. It's one indication of the health of the engine. Then you can look back and compare to see if the same cylinders are the higher ones or lower ones. I never get the exact same numbers in terms of percentage. It does vary a little bit, and I'm not sure why it's not exactly precisely the same, but the patterns are all very similar. And again, I'm using this just as one indication of the health of the engine to ensure everything that is okay. My understanding is the number 1 indicator is oil consumption. So if your engine isn't burning any oil, mine's not, thankfully, knock on wood, that's the best indicator of a healthy engine. So I hope that you find this helpful. I find it kind of a fun procedure. It really doesn't take that long. Once you've done it once, it's not a big deal at all. If you're changing the oil, you can just do this before you do the oil change. And it wouldn't be fun if you're doing it because you're having a problem and you're trying to find out where the problem is. And I feel for you if that's your situation. But hopefully this write-up will at least have helped a little bit to ease the pain of that by having it set out in great detail for you to follow so you can do the test yourself. Good luck.